All right, so here we are in our final video for this module, vectors. So vectors, if you go to the online notes, I put a clip there. It always reminds me of Universal Pictures' Despicable Me, the villain Vector. It cracks me up. I fell off the couch. I was laughing so hard the first time I watched it with my boys. But that aside, a vector is a directed line segment with both an initial point and a terminal point. So this is where it has both direction and magnitude. And it's represented by an arrowhead pointing toward the terminal point. For our position vectors, we're always going to use an initial point of 0, 0, and defined by its terminal point, AB, with those little pointy brackets on it. So if I have a vector AB, the way that this would be drawn is I would go over here, and this would be my vector AB. And we graph this by going, just like you would any other point in the coordinate plane, you go over A and up B. Over A and up B, just like you would any other point. So the vector has both direction and magnitude. So when we're measuring the direction, this angle here, theta, that is our direction. And the magnitude is denoted by, it's actually two sets of absolute value bars. That's the magnitude of V. And really, if you think about it, if you wanted to figure out how long V was, you would use the Pythagorean theorem. So it'd be the square root of A squared plus B squared for the magnitude. For the direction of this, you want to find out that angle theta. Now remember, you're given B and A. So in this situation, we're going to say the tangent of theta would be B over A. Or you could rewrite this as the arctangent or inverse tangent of B over A equals theta. Okay. However, when you're doing this, be aware of your location, i.e. quadrant. All right, so it's a bunch of different ways to do it. So here are a few examples I'd like to walk you through. We're going to solve for the direction and magnitude of each. Solve for the direction and magnitude of each. So for the first one, we're going to look at the vector 3, 3. Do a nice little easy one. And I'll call this vector U. So the magnitude of U would be 3 squared plus 3 squared underneath a radical. So this would be U would equal the square root of 18. Or 3 rad 2 if you go back and look at how to reduce radicals. Or you could say it's .243. Okay, so that's the magnitude. Now for the direction, this would be the inverse tangent of 3 over 3. So it'd be the inverse tangent of 1. inverse tangent of 1 equals theta. So we can say 45 degrees equals theta. Now, to kind of confirm this for you, if we were to graph this, 1, 2, 3, 1, 2, 3, not to scale. So there would be U, where this angle here is 45 degrees and its magnitude is 4.243. Try another one. Vector W has the point -6, -4, +6. So there's W. Okay, so when we're measuring vector W, the magnitude for W, that doesn't change in any way, shape, or form. So this would be -4 squared plus 6 squared, all underneath the radical. The magnitude of W would be square root of 52. Which is about 7.211. So that's the magnitude of W. The direction of W, though, this is going to take a different turn. Get it? Turn, direction, never mind. We need to find the angle from here to here, because this is how we measure our angles in standard form. We always start at the positive x-axis and go counterclockwise. So if we were to do our tangent, our inverse tangent of 6 over -4 for theta, we get theta to equal -56. I'm going to round to -56 degrees just for simplicity's sake here. So now we're at 56 degrees. Now there's an issue with this. It's -56. -56 would be down here. All right, but knowing what we know from the last couple modules, 56 degrees, really, this 56 degree angle is right here. So to find the red angle, if that's 180 degrees, we're going to do 180 minus 56, which would be 124 degrees. So that is our direction. This is our magnitude. Okay. So that's how you find direction and magnitude. And again, beware of your location, i.e. quadrant. So depending upon what quadrant you're in, you're going to either add or subtract to 180 or 360 degrees, depending upon the situation. So just to go back here for a second. So we've talked about drawing a vector and solving for direction of magnitude. So the last thing we're going to talk about is performing operations with vectors. All right, and there's only two operations we're going to discuss, all right? We're going to do vector addition, vector addition, and scalar multiplication. So for the vector addition, if you've got vector A with points A1, A2, and vector B with points B1, B2, then if you were to do A plus B, that would be A1 plus B1 and A2 plus B2. So, to show you what this looks like, we're going to do 3, negative 2, 3, negative 2 plus negative 1, 4. So 3 plus negative, so it would be 3 minus 1, negative 2 plus 4 when you add these together, giving us the final result of 2, 2. Now to show you what this looks like graphically, all right, because we call this vector here the resultant. All right, so we have 3, 2, 3, negative 2. 1, 2, 3, 1, 2. There's 3, negative 2. This is A. Then we also have negative 1, 4. 1, 2, 3, 4. There's vector B. Now what happens is that we're going to move these two and put them so that they're tip to tail. All right, so it's back 1, up 4. So from here we're going to go back 1 and then up 1, 2, 3, 4. So there is vector B. So basically it's like you're going to go from 0 to A, then from A to B. You're following those directions. So what ends up happening is you get this red vector here, the resultant R. And R happens to be at 2, 2. As vectors get larger and more involved and far more complex, this formula is the preferred way to go about doing it, just because it makes life a lot easier, a heck of a lot easier. So that takes care of vector addition. Scalar multiplication simply says if you have k times a vector a, b, this is ka, kb. So if we were to have like 3 times the vector 4, negative 2, this would become 12, negative 6. It really is as simple as distributing for scalar multiplication. So this can be combined to do different things. So for instance, for example, if we say u, vector u is 1, negative 8, and vector v is negative 2, 4, we can evaluate 2u minus 3v. So 2u would be 2 times 1, negative 8, minus 3 times negative 2, 4. So we'll just follow the process. Distribute 2, negative 16, plus, now I know it's a negative sign there. I'm going to distribute the whole negative sign. So when you distribute that negative, it becomes addition. That would become a 6, negative 12. Negative 3 times negative 2 is a positive 6. Negative 3 times a positive 4 is a negative 12. Now we're ready to combine. 6 plus 2 is 8, negative 28. And there you go. Oop, sorry about that. Here. There we go. So that's it. That's it for trigonometry, which is kind of cool. Maybe that's a bit of a relief. Maybe it's a bit more anxiety. So just to sum this up, all right, a little conclusion. What we've covered in this module so far, all right, we talked about right triangle trig. We did the unit circle. Right triangle trig, the unit circle. After we did that, we talked about the reciprocal identities. The reciprocal identities. Once we were through with the reciprocal identities, we talked about graphing trig functions. Once we finished graphing trig functions, we did solving trig equations. And then we ended it with vectors, okay? So a lot of this is just laying a foundation, a basis for what you'll be doing in the next course, pre-calculus. They'll go into all of this in a lot more detail, and you'll be doing a lot more interesting and fun things with this. So that concludes college algebra with trig. So nice job, everybody. I know this was a shortened course or late start course, so instead of having the full 16 weeks, you folks only had 14. We were really crunched for time. And you stuck it out, and thank you very much for all your hard work this semester. The only thing after this is the homework, the unit test, the discussion, and then the final exam will be coming up in a week or two. So again, thank you. And as always, if you have any questions, any concerns, please do not ever hesitate to send me an email. I'll do anything I can to help you, and of course, there's also office hours on Monday nights. All right, take care. Thanks.